So this is no mistake, we are in 4.3. We're going to study right triangles at this point. What we've learned so far are studying angles, whether we're measuring them in degrees or radians. Now we're going to apply that to studying the angles on triangles, among other parts of triangles. And that really is what trigonometry is all about, the study of triangles. When you walk away from this video, what you need, I'm going to start down here, is to be able to calculate what we call reference angles, so that includes knowing what they are. You need to use two special triangles. You need to be familiar with them and then use them. And then our ultimate goal is to lead up to evaluating 6 trigonometric functions, and we will be using this and this to do that. This video features my pumpkin that I won, and it could be scary for some, but overall it's just really helpful. It's a trig pumpkin. Alright, our first objective was to know what reference angles are. And a reference angle is if you let there be a standard form angle, so again, opening from the x-axis, the positive one, and then going in the counterclockwise, what we call the acute angle that's formed with that terminal side, and remember that terminal side is just the angle that we opened up with, this one right here. This is the initial. It's the acute angle formed by the terminal side of that angle, so here was my angle, and the horizontal axis. So if this were my horizontal axis, there's actually 2 angles that are formed, of course, the one that we opened up, but then also this acute one right here, which is what we want. The way we notate that is our theta, and then we put a little prime or apostrophe up there. So it's theta prime is how you might see that sometimes. Alright, so let's actually work with these. To calculate the reference angles for these, I'm going to go ahead and sketch them. So I'm going to start in my standard position. So there's my initial side, and I'm going to open 90, 180, went too far, sorry, 120. There, it would be a little past the 90. Okay, but that's okay, I'm going to use this, because this right here is the reference angle. If we draw and emphasize the x-axis here, there are 2 angles that are formed, right? We want the acute one, because the terminal side and the horizontal axes form this acute angle. So I'm going to label this theta prime. So what is this angle right here? Well, to calculate that, what you can see is there's this leftover that we didn't quite reach when we went only the 120. So 120 plus what is equal to 180, or in other words, 180 minus 120 is equal to 60 degrees. So our reference angle, prime, is equal to 60 degrees. Alright, let's look at 30 degrees. Let's go ahead and open this up. So here's my standard form angle. Okay, we're going to call that theta. Alright, and again, we're going to emphasize the x-axis, and so this time we're not going to go all the way over here for my angle. We're going to go here for the reference angle, and you can see that the reference angle is in fact the same thing as the angle itself. So it's 30 degrees because there is the acute angle formed with the x-axis and the terminal side. And then 200, let's go to 200, so we're going to go all the way past the 90, all the way past the 180, and a little bit past the 180 to 200. Okay, so again I'm going to emphasize my x-axis, and I'm looking for the acute angle formed. Here it is. So this right here is theta prime, and then to calculate that, what I know is I went all this 200 way around, and I want to figure out what is this left over that I went past the 180. So I'm going to subtract off 180, and then therefore our reference angle is 20 degrees. So the reference angle of 200 degrees is 20 degrees. That was the first objective that we've done there, to calculate reference angles. Now we got to look at our 2 very special triangles that we're going to look at, that we're going to be using. So the first thing that we need to do is review the parts of a right triangle. So recall that a right triangle is just a triangle with a right angle, so I'm going to label it there. So then all right triangles have what we call the hypotenuse. It's the longest leg, and it's the side that's always opposite or across the way from wherever that 90-degree angle lies on that right triangle. So there's my hypotenuse. We have 2 legs, those are the sides that make up the 90-degree angle in that right triangle. And then we have an adjacent side. So in order to have an adjacent side, we have to have an angle of study. So I'm just going to say we're studying this angle right here. So we're going to be now looking at the angles, or these parts of the right, or of these triangles that we're going to be studying in trig. And if you're going to study from an angle, you have what we call an adjacent side. That is the leg touching the angle of study. So this right here is my adjacent. And then we have the opposite side, which is going to be the side opposite to the angle of study. So looking across the way. Keep in mind, if we were studying from this angle right here, this would have become the opposite. That would have been the adjacent. The two very special triangles that we're going to study right now, one of them is called the 45, 45, 90 triangle. So this is going to be my right angle, which makes these two the 45. They're equal, which makes the sides opposite of those two congruent angles also congruent. Okay, so I'm going to use a quick proof here. We're going to let our special triangles for now be a hypotenuse of 1 always. So we're just going to use a hypotenuse length of 1. We're going to use our good old Pythagoras friend and his theorem, a squared plus b squared equals c squared, which all that is a leg squared plus a leg squared equals the hypotenuse squared. So what we have here is a squared plus, and then knowing that these were the same length, I'm going to call this a, so therefore this would be a. It's going to be a squared plus a squared, the same length of the leg squared plus the same length of the leg squared equals 1. So now we have 2a squared equals 1. So this is where it gets a little tricky. If you ever take the square root of a quotient, go ahead and individually square root the top and the bottom. So what we get is 1 over the square root of 2, because this doesn't become a nice pretty number, so we're going to leave it. But this would be our answer, except for the fact we do not like radicals on the bottom. Don't leave radicals on the bottom. So to get rid of that, we're actually going to square this, or in other words say I'm going to multiply the square root of 2 by the square root of 2. Okay, which means whatever you do the top or bottom, you got to do the top. So we're going to get the square root of 2, and keep in mind this is just the square root of 2 squared, so the radicals undo each other. There we have it. So the thing that you need to know is when you have a special 45, 45, 90 triangle, is that the side lengths are going to be 1 for the hypotenuse, the square root of 2, and the square root of 2 over 2. So here, you can see that very special triangle on my pumpkin, my helpful pumpkin. Alright, I'm not going to go into the proof of the side lengths for the 30, 60, 90, but this is also a very special triangle. And what we're going to be looking at are those side lengths here as well, and knowing those. So this, again, the hypotenuse is 1. The shorter leg of the 30, 60, 90 is the length 1/2. The longer leg, if this was 1 inch or something, or 1 foot, then this would be the square root of 3 over 2 feet. And again, that is a very special triangle too, worthy of being on my pumpkin. So the idea is that these lengths need to be memorized with these two special triangles. So we have met objective 1 and 2, so now what we're doing is the overall objective. The big objective is to evaluate our trig functions. Keep in mind the definition of a trig function. All they are equations, of course, where you input specifically an angle and you output a side-to-side ratio. So we're going to be looking at these triangles, and we're going to input an angle from one of the angles off that triangle, and what it will output is a specific side-to-side ratio. Just like if you put like y equals x squared, you input a number and know that you're going to get a squared output for x squared. Same thing here. You know, if you put sine as one of our 6 trig functions, if you put in one of the angles on the triangle, so for example 30 degrees, you're going to get a side-to-side ratio, a specific one, according to the sine. So the 6 trig functions are sine, cosine, tangent. Those are the main 3. And then they have brothers. These all have a special relationship, and we'll go over those in a second. But it's weird, the s goes with the c goes with the s. And then we have tangent and cotangent. So these guys share a special bond, these guys share a special bond, so do these guys. The 3 major trig functions, sine, cosine, and tangent. So just like we have abbreviations for like 3 plus 4, we use our symbol, of course. These do as well. So the symbol, it's very recognizable to the sign. It's sin of theta. So again, what we're doing is we're seeing this operation, and we're saying I'm going to plug in an angle from a triangle. And so what this function will do, instead of adding for us, this function will look at this particular angle of that triangle and output the opposite over the hypotenuse side of that triangle. Cosine is the adjacent over hypotenuse. Tangent, if you input an angle into tangent from a triangle, it will give you the opposite over adjacent. So saying for this is so ka toa. And yes, the ka has to be kind of emphasized especially, so you make sure that you get an A in there. So that's so important that we have. So ka toa. Alright, so here's the remaining of them. So again, I said that sine and cosecant have a special relationship. They're what we call reciprocal functions. You can just refer to the sine when you're evaluating cosecant of an angle. You can refer back and say, alright, well, if I'm trying to evaluate cosecant, sine was the opposite over hypotenuse. Cosecant, whatever you got there, is just going to be flopped around, the hypotenuse over opposite. Secant, hypotenuse over adjacent. And then cotangent, brothers with tangent, it's going to be the opposite of toa, adjacent over opposite. AO. So there are some steps that you're going to want to use. So let your terminal side length be 1. When you open up a standard form angle, let that terminal side be a length of 1. Use the reference angle from the x-axis. Right? We know how to calculate that from side 1. Form a right triangle with a horizontal and vertical length to get to the end of the terminal side. Keep in mind, any point when you open a terminal side and let that be 1, well, that's a length, but we can get to that length or that spot that it ends by going a horizontal and vertical route, because everything is made up of an x, y value, right, on the coordinate grid. So we just need to go the length of the x, the length of the y to get to those points. Same thing here. Go the length of the x, go the length of the y. There's your right triangles. Okay, so you're going to form these right triangles. Evaluate the 6 trig functions with the observed angle, at the origin. So you're going to stand on the origin and you're going to observe from that angle. Watch out for negatives, get radicals off the bottom, and simplify. So let's practice with this. I'm going to go ahead and sketch out a 210 degree standard form angle. Again, I'm going to let this be length 1. That was my first step. Let's go ahead now and calculate this reference angle. I went all the way to 210, right? And then what I wanted to do was take off this 180 to figure out what was left over here. So minus 180, it was 30 degrees over. So that is our reference angle equals 30 degrees. Okay, and I'll put my prime there. Alright, so now we're going to go form a right triangle with a horizontal and a vertical length. So we know that I have to go over and down to get to this point. What you'll see is there is my right triangle that was just formed. And now we're going to use our special triangles, my 30, 60, here's my 60, 90 triangle. And the longer leg, again, of that 30, 60, 90 is going to be the square root of 3 over 2. So the square root of 3 over 2. But do note that we have to be aware of the negatives. Now that we're on the coordinate grid, the length of this triangle is actually a negative direction, so we're going to have to say, well, it's negative square root of 3 over 2. Down, this smaller leg on that 30, 60, 90 is 1/2, and again it is down, so we do have to have it negative. Now we're ready to go. We're going to now evaluate this triangle using our 6 trig functions. So sine of this angle as we stand at the origin, as we stand at this 30 degree angle, the sine, and actually I'm going to write sine of 210. It's weird because we're evaluating the sine of 210, but we're using the reference angle, so truly we're just using the sine of 30. But because that 210 places us at negative values, we have to be cautious of that. So sine of 210 is going to be, let's look at O, opposite over hypotenuse, it's negative 1/2. Okay. Cosine of 210 degrees is going to be ka, so adjacent, the side touching, over our hypotenuse, and I'm not even going to put it over 1, I'm just going to leave it like that. And then tangent, toa, it's going to be opposite, negative 1/2, all over the adjacent, so negative square root of 3 over 2. Now this is what we call a compound fraction. We don't like those. Don't leave it like this because it looks confusing. So what we're going to do is we're going to turn this compound fraction, which is truly just division, into a multiplication problem. So we're going to turn that division into multiplication, but that means we're going to have to switch this to the reciprocal. So I'm going to just go ahead and swap the numerator and the denominator around. Okay, we can change any division problem into multiplication like that. So now when you cancel those off, you get 1, 1. I'm actually going to cancel off the negative 1 and the negative 1, right? We have multipliers of negative 1 in here, 2 of them, and they're going to ultimately be positive. So now, here we are. Here we have it, our answer. Except for I still don't like that because we have a radical on the bottom. So I'm going to multiply the top and the bottom by the square root of the square root of 3. And what we get is the square root of 3 over 3. Because the square root of 3 times the square root of 3 is just the square root of 3 squared. And the radical and the square undo each other. So this is our final answer. This would have been okay, but we really don't like radicals on the bottom. Cosecant now that we got our 3 main ones, these ones are fairly simple. What you do is you just refer back to the sign and say, okay, I can flip these, so it's negative 2. Otherwise, you could have said, alright, so is h, this would be h over o, so you would have to say, it's h over the negative 1/2. And when you do that keep switch again for changing division into multiplication, you would have gotten the very same thing. Okay, but otherwise you can just refer to the brothers, the cosecant to the sine, and then the secant to the cosine to just flop them. Again, we get a radical on the bottom, so let's get rid of it. So we're going to get negative 2 square root 3 all over 3. And then cotangent and tangent, they go together. And so you could flip this, but I'm going to actually flip the original one that we had here, the square root of 3 over 1. Okay, otherwise you would have been doing this because you would have flopped that, but then you got to get that off the bottom. And so you would have 3 square roots of 3 over 3, and then you'd have to cancel those out, and you'd still got this. Alright, so that's evaluating trig functions of certain standard form angles, what we've been building up to. Alright, finally let's look at this. I'm going to get you started. Evaluate the 6 Evaluate the 6 trig functions by memory or by constructing an appropriate triangle for the given special angle. So let's go. This is a special angle because it's going to line up with one of these. So if I had cosine of 60 and you don't know where to start, well, let's start by sketching that angle. So I'm going to go ahead and sketch 60 degrees. There it is. Okay, and my reference angle is going to be 60 degrees. I'm going to let my terminal side that I just sketched be 1, and there is a horizontal and a vertical distance that I have to use to get to that point, right? So now I have a 30, 60, 90 triangle. We're going to go ahead and say my shorter leg is 1/2, my longer leg is the square root of 3 over 2. You're going to be using these so much, so you will memorize these. And now you just want the cosine of this. So that's simply going to be 1/2 because I wanted adjacent, the adjacent side. Thanks, pumpkin. Okay, I'm going to leave these for your doing because we did something similar to that. Keep in mind that you will be using this special triangle too.